This is number 13 from page 439. We're going to do this with long division first, and then I'll show you how synthetic division could get you to the same answer. Here we go. Let's see here. They want you to take 3x minus 2 as your divisor. It's going to be out front. You're going to divide it into 6x cubed plus 8x squared. Word of caution. If that little plus x wasn't there, I would put plus 0x and hold a spot for it. All right? But it's there, so put it in. But if something is missing, whether it's long division or synthetic division, hold its place with a 0 so you don't forget about it. So when you're doing long division, you look at the front term and the front term and think, what would go up here? What would go up here that you would multiply by 3x to get 6x squared? To get 6x cubed, you would multiply by 2x squared, right? You get 6x cubed. Now we have to multiply here, which I just did. Here would make minus 4x squared. It's important in long division to put a line under it and subtract this whole quantity. I want you to write that every time, minus parentheses, so you don't forget that you're subtracting. Because 4x squared would be a mistake in the next line. Double minus makes plus for 12x squared. If you're wondering what happened to these guys, they canceled. If they don't, you did it wrong. Start over. Bring the x down and think about now how 3x would multiply. What would it multiply by to make 12x squared? Yeah, 4x. Now we distribute the 4x to the divisor. 4x times 3x is 12x squared minus 8x when you multiply by the negative 2. Subtract this quantity. These cancel. If you don't, you're in trouble. If they don't, you're in trouble. X double minus 8x is 9x. The minus 6 comes down, just like the x came down before. And we multiply 3x times 3 to get 9x minus 6. And when you subtract a quantity from itself, the remainder is 0. So the answer to this division problem is right here. 2x squared plus 4x plus 3. All right. Now, here's how you would have to do that synthetically. I would have to tell you that one of the roots of this problem is 2/3. You would have to know that if 3x minus 2 is a factor, what would a root be? You find a root by setting the factor equal to 0. Add 2, divide by 3. So if 3x minus 2 is a good factor, and it is, then 2/3 would be the number here to start the synthetic division. All right? The root goes into the synthetic division as is. You don't have to use the opposite or anything like that. You would divide 2/3 into the coefficients from the numerator. 6, 8, 1, and negative 6. And you're ready. Drop the 6, multiply. 2/3 of 6 is 4. Add. 2/3 of 12 is 8. Add. 2/3 of 9, 6. Add. 0. Happy. All right? So, we would have a good solution here. And knowing this, we would have x minus 2/3. Remember, if 2/3 was a root, x minus 2/3 would be a factor. All right? But the other piece is going to look a little bit different. Because 6, 12, and 9. Wait a minute. In the highlight, I had 2, 4, and 3. Let's think about what's going to happen here. So the dilation is going to come into play, right? This was 6x cubed. Now it's 6x squared plus 12x plus 9. And I ask you this. What factor do 9, 12, and 6 have in common? 3. So you could factor out their common 3. And when you did, if you took a 3 away from 6 and divided it out, you'd have a 2x squared. Divide a 3 out from 12. 4x plus 3. Now, does this highlighted piece look like the yellow highlighted piece? Yes, it does. And if you distributed 3 to the x minus 2/3, guess what you would have? 3x minus 2. 3x minus 2. So it's the same thing. It looks a little different, but it's the same answer. It's the same factored form. So that's how long division and synthetic division can work hand in hand, or can do the same thing for you.